If you've been following along with the series, at this point you have 6 new custom nodes in your node library, beginning with the main UV grid node itself, the UV brick generator node, and the vector flip node, accompanied by our 3 utility nodes, the much beloved fader, the value mix, and the value to direction. To begin this video, we're going to be creating 3 new custom nodes. And the functions for those custom nodes are all ready to be found inside our UV brick node. We're going to copy and create node groups of this bunch of nodes, which creates a trapezoid profile from a linear gradient, followed by this bunch, which creates a radial gradient from a UV map. And finally, this little trio over here, which converts a linear gradient into a parabolic curve. Now, I'll begin by duplicating these nodes and we'll move them slightly up to keep them apart. Here I'm going to create some reroutes to help me remember where the inputs and outputs go as far as these nodes are concerned. I'll select all the nodes and the reroutes included, duplicate and move them up. I'll do the same thing here, mark my input and my output, duplicate everything, move them up, and let's begin making some groups. Control and G. I'll connect my input and my output. I can now get rid of these reroutes. This node is essentially already done, but I'm going to add the ability to blend back and forth between the original unaltered input and this altered input, which is the parabolic curve. I'll do that with a value mix, with the original input in the top and the altered input in the bottom. I'm going to set the factor to 1, so I get a default of 1 when I create the input factor. And now I'll swap out the result of the value mix for the output value. There you go. That's that one done. And I'll name this one value curve. Moving on, I'll select this little bunch and Control G to make a node group. Now I'm going to make one change to this one. This is the bunch of nodes which creates a radial gradient for us. The first thing that I don't want is this subtract node, which I introduced to invert and to clamp the gradient where we used it previously. I don't need that anymore, so I'll Control and X to delete it. This is still going to be my output value, so I'll hook that up and delete the reroute. Now over here for the inputs instead, I don't want to use the separate coordinates, the separate U and V coordinates. I would rather a single vector input, which I'll then separate with a separate X, Y, Z. And feed the X and the Y. Remove those reroutes. Now to avoid the vector created on the outside of the node group being split apart like this one, I'm going to use the vector input of a noise texture to create this input and then delete the noise texture, hook that up. And that is our value distance node, as I'm going to call it, because that is exactly what this node does. It creates a radial gradient by measuring the distance of any given pixel from the center point of the gradient, and we now need a way to specify that center point. We'll do that by creating some new input sockets connected to the bottom of these 2 subtract nodes. We got one for the U channel and one for the V channel, so I'll name them appropriately. Center U and Center V, which I'll abbreviate to CU and CV. That's another one done, and this one I'll call UV distance. The last of the 3 is our profile group right here. Select them all and Control G, create the group. Now I'll hook up my inputs. There are 4 of them. These inputs bear a striking similarity to the inputs of our UV brick node. If you remember, we'll leave the first one as input, the second one I'll set to size, the third space, and the fourth edge. Now I'm going to extend the node a little bit by introducing a curve node, a value curve. And a way to blend back and forth between the soft edges, which is exactly what this value curve node gives us. So I'll rename the factor to soft edges. The final thing to do is to multiply the height output, which is precisely what this is. So I'll rename it as such, height. And we need to, as we did before with our bricks and our tiles, we need to multiply the height output by the value of our edge right there. So I'll drop in a converter math node, multiply, hook it up to the edge input, and now I can tidy up these noodles by stacking them one on top of the other. And now with the height taken care of, I can move on to making a mask exactly like we had for our UV brick. We'll do that by using the output of these two subtract nodes. That's the top node and the second last one, which is the last subtract node. This one and this one. They'll go to some greater than nodes with a threshold of 0. The first subtract and the last subtract. We'll then multiply these two results together and we'll feed that to our output. We'll call that mask. And I'll flip the order. Let's tidy these up. And we'll call this node done. We'll give it the name UV profile. Let's have a quick look at the inputs of the UV profile node, more specifically their default values. The input we don't really have to worry about. The size I'm going to set to a default of 1. The space will have a default of 0. Edge a default of 0.1 arbitrarily. Soft edges, I think I'll turn soft edges off by default, so I'll leave that at 0. Let's move on. Those are our 3 new nodes. Click the shields to keep them forever, and we can delete them from the UV brick. And now let's move on and put them to some use. We'll create a new material. And let's start off with a UV map node, accompanied by a UV grid node. And we'll use the standard output. I'm going to separate it and concentrate on the Y channel. Let's get a preview. Turn off my overlays. Now let's begin by adding a UV profile node. Switch to the height output and let's see what we're getting. Very much like the UV brick node, we must provide the same value to the size of the UV input as we're using for the relative component of the vector output by the UV grid node. In this case, I'm concentrating on the Y channels, so I'll use the height. In this case, the two values are absolutely the same, but that may not always be the case. 0.1, and you'll see the result we're getting here. Now, as was the case with the UV brick node, a matching size and edge value will not do. You'll typically want the edge value to be less than half of the tile size itself. We'll set that arbitrarily to 0.02, for example. And let's have a quick look at a displacement preview of what we're actually doing here. I'm going to turn on my world lighting. I'm going to reduce or tone down the color of this plane for a second. I'm also going to subdivide the plane. So I'll tab into edit mode. It's already subdivided. That's a subdivision by 10. And I have a subsurface modifier. I'm going to set the viewport levels to 4 and the render levels to 5. That should work. Let's go to cycles and set the displacement mode of our material to displacement only and not bump only. I'll bring these values down here to sit alongside my displacement node, which takes the height output mid-level of 0 and connect the displacement to the material output. Now let's see what that has done. That's what the profile does. If I mute the profile, we get a sawtooth effect going from 0 to height in this case, which is 0.1. So that's 0 to 0.1. If I turn on the profile, it gives me the trapezoid profile shape that I wanted. I can reintroduce the soft edges as I see fit. And we have created some strips or bands, possibly some straps, whatever way you want to look at it. Let's take this idea a little bit further. And I'm going to use an original unaltered UV map for once, concentrating on the X channel. Remove the displacement from the material temporarily, just to speed up my viewport. And turn off world lighting. Now then, let's have a look at some mathematical functions carried out on this linear gradient and what we can do with it. Drop in a math node. The function in question for now is a trigonomic function, sine. We're going to be creating a sine wave from this linear gradient. Now, the sine wave works particularly well when its input value is relative to pi in one way or another, so 3.14. If I multiply my input value by pi, you'll see that I've got a 0 to 1 to 0 peak, essentially, of the sine wave. If I enter pi times 2, we've got some blackness going on here. We don't see any gradient, but that's because with a color value you can't represent minus numbers. But believe me when I tell you that this value is actually going from 0 to -1 here in the center and back to 0 here. So we're getting a peak and a trough of the sine wave by giving the sine node the value of pi multiplied by 2. So I can use a multiply node with an integer value in the top, 2 for example, and pi in the bottom, plugged into the bottom of this multiply node, and now I can choose how many peaks and troughs, how many instances I get in any 0 to 1 gradient or UV map by increasing this integer right here. For now I have 2, meaning 1 peak, 1 trough. If I go up to 3, 1 peak, 1 trough, 1 peak, etc., etc. You can see how this works. If I set that to 10, that gives me 5 peaks, 5 troughs, or 10 instances, as I'll call them, to avoid repeating peak and trough over and over. And there is a relationship now between the instances of the sine wave created here and the number of tiles of my UV grid, because I have 10 instances and I have 10 tiles because I input a tile size of 0.1, 0.1 dividing into 1 10 times. So if I were to, for example, use a value input node with a value of 10, I can plug that directly into the top of the multiply node. And now I can use a divide node. Not there. And I'll divide 1 by this input number and provide that to the width or height value of my UV grid node. As you can see, things have got a little messy and turned around, and I've had to move nodes in all sorts of directions. Now I can do this a different way. For example, here I decided to provide the number of instances that I want, and that goes straight to the sine function, whereas I had to transform that number before providing it to my UV grid. I had to transform it into tile sizes, essentially. I could do it the other way. I could input tile size here and then transform the value that gets sent to the sine function. This is just an example of how we can move fewer nodes around to take better advantage of the space available to us in any given network. Nothing more than that. Let's change things around. I'm going to disconnect that divide node, and here I'm going to input my tile size. You'll see that the sine wave function gets broken, but now I can drop the divide node onto this noodle, swap the noodle into the bottom input, and there you go, we've got our instances back. 2 different methods for accomplishing the exact same result. Pick the one you like best and go with that one. Now then, let's address the height generated by our sine function right here. As I mentioned before, these values go into minus numbers, which will cause problems when we come to using material displacement. So I'm going to avoid that by transforming the -1 to 1 range of the sine node into a 0 to 1 range by multiplying by 0.5 and then adding 0.5. There we go. Now we got 0 to 1. I'm now going to multiply this output by the output mask of my UV profile so that this elevation sine function will not affect the spaces between the bands that we created down here. Simple question of a math node set to multiply, and the mask goes into the bottom. We should also introduce some height control for this function, for this setup, because this will give us 0 to 1 displacement, being way too large for our needs, certainly for this example. I'll drop in another math node. Actually, no, I'll duplicate this one. And let's get a better idea of the displacement that we're getting by using an actual displacement preview. This is now my height output, displacement to displacement, and we can see that something is going a little awry here. I'll turn the subsurface back on and reactivate world lighting. Okay, so that's what that looks like for now. I think we definitely need to reduce our height. I'll drag that down here at the multiply node. Let's zoom in a little. Something like that should work. No, maybe a little bit more. Okay, now then, let's add the height result of the UV profile node with a math node set to add height into the bottom. And now we've got some rippling bands going on. 0.04 for the sine height. Yeah, that'll work. Looks good. Now we can do a little more with our UV grid. I'm going to move these two nodes downwards and out of the way. Let's duplicate this separate XYZ node and we'll take the stepped output. The Y component of that stepped output will add to the X component, which is being fed into the sine function right here. Take the Y, hook that up, and now we get our bricks offset, which is creating this alternating wave effect going on. Looking very interesting. Let's come down and have a look at our space and edge controls here. We're going to need very fine control, so I'm going to use fader nodes, 2 of them. I'll use the factor output, top one to the space, bottom one to the edge. Now I can control the sizes much more precisely. Let me show you the effects of the space, which are very pleasing and clean, I find. Now then, we have one layer, let's call it, of waving ribbons or bands. Let's create another layer by selecting all of these nodes, excluding the fader nodes, and we'll Control-Shift and D to duplicate them and keep connections. Drag it down a little bit. Now I'm going to swap the components of all of these separate XYZ nodes, so X for Y and Y for X. This X goes to Y, this Y goes to X. And the same thing here. Let's have a quick look at this height map and see what we're getting. Predictably, we're getting a similar alternating waving pattern, but running vertically as opposed to horizontally. And one final change I want to make is with a simple add node. Again, right here on the sine function. And I want to add the size value right here. Now then, I'm going to go back to layer 1, preview the displacement of layer 1. And now we're going to combine these two layers with a math node set to maximum. I'll drop that onto this noodle right here. And now when I connect to layer 2, check that out. We got some woven bands going on. We can control the sizes of both layers simultaneously. There we've got some microphone mesh going on, I think. We can also control the height function. We must do it similarly for both of the layers. So that means we should control both of these multiply nodes. Let's do that with a fader. I'll drag it over here temporarily. And we'll use the factor output into both of these multiplies. And we'll bring that over here so we can control everything from one spot. You got control of the height of the hump of the straps, control of the edge, which also to a certain extent controls the thickness of the straps, and we can control the space between each of the threads, strings, straps, whatever you want to call them. We can get our hands on a leather texture, a leather height map from the texture repository of our choice. I'll hook it up with a UV map. And I'm probably going to need to scale the texture, so I'll add a vector math node set to multiply. And I'll set X and Y to 1 for now, for no change. Now this is going to be a height map, so I'll separate the color and use one channel connected to a fader node so I can control the height. I'll set that to 0. And now we can very simply add that to our height map. I'll zoom in a little bit because I want the detail to be very fine. Drag it up nice and slowly. As a matter of fact, I'm not going to add this to the displacement output. I'm going to give this to a bump node. And we can see the super fine detail in the normals as opposed to the displacement, which would require an awful lot of geometry. Now then, let's bring in the leather bump. There it is. As I imagined, it looks a little big. Let's scale it a touch. Looks good, but now I think the height is a little too big. There we go. Bring down the specular a little. And the roughness. And I think I'm going to reduce my height map even more. As a matter of fact, I'm going to permanently reduce it with a multiplication. I can now compensate a little bit with my fader. That's nice. And there you have it. You got some woven leather straps for your medieval armor, I guess. Possibly a carrier basket. I don't know. Whatever you can think to use it for. Be my guest.